Okay. The first thing that we are asked to do is to derive the Pythagorean identities. That means that we're going to start with a right triangle, and we're going to assume that we know the Pythagorean theorem. We don't have to prove the Pythagorean theorem. We're given that. And we use the Pythagorean theorem to get these three Pythagorean identities. Now, let me just real quickly show you my handout, how I normally organize my handout here. I've got three things that I'm needing to prove. So I've got my paper divided up into three sections. I cannot write that small using a marker, so I'm going to put this on a separate sheet of paper. But if you're following along here, you need to try and organize this into three different sections. So I'm going to start off by sketching out a right triangle. You are going to have to prove one of these on your test next week. This is going to be theta. This is A, this is side B, and this is side C. So I'm going to start off by writing down the Pythagorean theorem. A squared plus B squared equals C squared. And then I'm going to divide both sides of my equation by A squared. And when I do, each term gets divided by A squared. So my second step here is when I divide by A squared, I have divided by A squared there, there, and there. Now, one thing I want you to notice is that I have my Pythagorean theorem here. That's my first step. And then I come down here and I then divide by A squared. I don't do that to my first step, right? So take the time to be sure you write out both of those steps. Now I'm going to rewrite this part. This is just 1. A squared divided by A squared is 1. This I'm going to rewrite as B over A in parentheses squared. This I'm going to rewrite as C over A in parentheses squared, right? I'm using my laws of exponents to rewrite that. So this is cotangent of theta squared. Be sure that that cotangent theta is in parentheses and the squared is outside your parentheses. C over A is hypotenuse over opposite. That's cosecant. So this is cosecant of theta squared. So again, cosecant theta in parentheses, the squared outside the parentheses. And then I can rewrite this like we normally see squareds written when we're talking about trig functions. This is cotangent squared theta. This is cosecant squared theta. And that is that last Pythagorean identity. So we started off with the Pythagorean theorem divided by A squared, and then just use our trig definitions to substitute in and simplify to get it in the right format. Okay, second thing I want to do, right, still starting off with the Pythagorean theorem, now I'm going to divide both sides by b squared. Right here I divided by a squared. Now I'm going to divide by b squared. Okay. So I'm going to write this a over b in parentheses squared. B squared divided by b squared is 1. And this is c over b squared. So a over b, opposite over adjacent, is tangent. So this is tangent of theta squared, and then plus 1. Hypotenuse over adjacent is secant. So this would be secant theta squared. And then rewriting this to where we're getting rid of the parentheses and just writing it as tan squared theta plus 1 equals secant squared theta. Any questions with either one of those two problems? Okay, so here I divided by a squared. Here I divided by b squared. My third way is to divide everything by c squared. So I want y'all to work through that on your own while I take attendance. You're going to start off by writing down the Pythagorean theorem. Then we're going to divide everything by c squared. And this is a over c squared. This is b over c in parentheses squared, and this is 1. A over c, opposite over hypotenuse, is sine. So this is sine squared. This is cosine squared. And the way that you would write this without parentheses is sine squared theta plus cosine squared theta equals 1. And that formula right there, I suggest that you memorize that instead of having to go back to your reference sheet every time that you need it. The other two formulas, actually, you can, well, they're on your reference sheet, but you could easily get those other two formulas from this formula if you divide everything by sine squared or divide everything by cosine squared. All right, one thing I want to mention here is to be sure that you understand sine squared theta does not equal sine theta squared. Those are two different things. And if you're writing this down when you're supposed to be writing this down, I'm going to count off for that. And this is going to show up a lot in chapter 3. So you do need to be sure that you understand the proper way to write everything.